गुड मॉर्निंग स्टूडेंट्स, आज हम डिस्कस करेंगे एक्सरसाइज 9.3। लेट अस डिस्कस द फर्स्ट क्वेश्चन ऑफ 9.3। सबसे पहले हम देखते हैं कि हमें गिवन क्या है और हमारा टू प्रूफ क्या है। उसके बाद वी विल गो टू द प्रूफ, अवर प्रूफ। सो फर्स्ट ऑफ ऑल हमें जो गिवन है कि इट इज़ गिवन टू अस दैट E इज़ एनी पॉइंट ऑन मीडियन ऑफ ट्राइंगल ABC और एंड हमें प्रूव करना है दैट एरिया ऑफ ट्राइंगल ABE इज इक्वल टू एरिया ऑफ ट्राइंगल ECE। व्हाट दिस क्वेश्चन सेज कि एक हमारे पास मीडियन है जो कि हमारी ट्राइंगल को दो इक्वल पार्ट्स में डिवाइड करेगा। वी नो दैट अ मीडियन डिवाइड्स अ ट्राइंगल इन टू इक्वल एरियाज और उसके ऊपर एक पॉइंट है E पॉइंट एंड वी हैव टू प्रूव दैट these two triangles are equal in area. Okay, let us see how we're going to do it. Now it is given to us that AD is median of ABC. So इससे हम conclude कर सकते हैं कि जो एक मीडियन है वो एक ट्राइंगल को दो इक्वल एरियाज में डिवाइड करती है। वी नो दैट। और इससे हम कंक्लूड कर सकते हैं कि एरिया ऑफ ट्राइंगल ABD इज इक्वल टू एरिया ऑफ ट्राइंगल ACD। लाइक इस ट्राइंगल का एरिया इज इक्वल टू एरिया ऑफ दिस ट्राइंगल। ओके, देन हमें यह भी पता है कि ED इज ऑल्सो द मीडियन ऑफ ट्राइंगल BEC। प्लीज़ यहाँ पे करेक्ट कर लें, इट इज़ ट्राइंगल BEC। सो उससे हम ये कंक्लूड कर सकते हैं कि एरिया ऑफ ट्राइंगल EBD इज इक्वल टू एरिया ऑफ ट्राइंगल ECD, क्योंकि हमें पता है कि एक मीडियन एक ट्राइंगल को दो इक्वल एरियाज में डिवाइड करती है। सो बाय सब्ट्रैक्टिंग आवर इक्वेशन 2 फ्रॉम इक्वेशन 1 वी कैन गेट दैट area of triangle ABE is equal to area of triangle ACE. Let us discuss question number 2. In question number 2, we have triangle ABC and E is the midpoint of median AD, and we have to show that area of triangle BED is equal to 1/4 of the area of the ABC. अब देखते हैं कि फिगर में देखते हैं कि हमें क्या प्रूफ करना है। इन एक्चुअल हमें प्रूव करना है कि जो एरिया जो मैं इस ब्लू कलर के साथ शेड कर रहा हूँ, इस ट्राइंगल का एरिया, ये जो पूरी हमारी बड़ी ट्राइंगल है दैट इज़ ABC, उसका 1/4 है। लेट अस गो टू द प्रूफ। वी नो दैट एरिया ऑफ अ ट्राइंगल इज हाफ ऑफ बेस इनटू हाइट। तो इसलिए हम लिख सकते हैं कि एरिया ऑफ ट्राइंगल BED इज इक्वल टू हाफ ऑफ BD इंटू DE। अगर आप देखोगे यहाँ पे BD we can take it as a base और DE we can take it as our height. Now E is our midpoint of AD. जो E है वो AD का midpoint है, तो हम कह सकते हैं कि AE is equal to DE. So AD भी हमारे पास एक मीडियन है जो BC का मीडियन है। So we can say that BD is equal to DC. So by both these statements हम conclude कर सकते हैं DE is equal to half of AD and BD is equal to half of BC। और इसको हमने फर्स्ट स्टेटमेंट दे दिया एंड वी हैव गिवन दिस आवर सेकंड स्टेटमेंट। सो इससे हम कंक्लूड कर सकते हैं कि एरिया ऑफ BED इज इक्वल टू हाफ इंटू हाफ ऑफ BC इंटू हाफ ऑफ AD। इसको मैं थोड़ा सा एक्सप्लेन करता हूँ कि इन फर्स्ट स्टेप वी हैड गिवन दैट एरिया ऑफ ट्राइंगल BED इज इक्वल टू हाफ ऑफ BD इंटू DE. सो अब मैं क्या करूँगा, BD की जो वैल्यू है दैट वी हैव फाइंड हेयर, कि उसको हम सब्स्टिट्यूट कर देंगे। हाफ ऑफ BD की जगह मैं लिख देता हूँ हाफ ऑफ BC इंटू, और DE की जगह मैं वैल्यू सब्स्टिट्यूट कर दूंगा हाफ ऑफ AD। अब मैं क्या करूँगा कि ये जो हाफ है मेरे पास, लाइक ये वाला हाफ और ये वाला हाफ, इसको मैं बाहर निकाल लूँगा और मेरे पास बाकी क्या बचेगा, मेरे पास ये तीनों बच गए। सो नाउ आई विल रीअरेंज दिस एज हाफ इंटू हाफ ऑफ BC इंटू AD। अब एक बात आप नोटिस करें, व्हाट इज द एरिया ऑफ ट्राइंगल ABC? एरिया ऑफ ट्राइंगल ABC is equal to area of ABC is equal to half of base into height. Now our base is here BC and height is our AD. Okay, so I can write it up as area half of BC into AD। अब मैं इन सब की जगह, instead of everything here, I can write it up as area of ABC. So I will substitute the area of ABC here, so आगे मेरा सेम रह जाएगा 1/2 इंटू 1/2 इंटू एरिया ऑफ ABC, so it becomes 1/4 is multiplied by area of triangle ABC. So hence we have proved what was our true proof. Let us discuss question number 3. In this question we have to show that diagonals of a parallelogram divide it into 4 triangles of equal area. Here O is the midpoint of AC and BD. We have make a parallelogram which is ABCD, and O is the midpoint of AC and BD, and diagonals of bisect each other. In triangle ABC, BO is median. First of all, we have taken this triangle ABC, and OB is our median, ABC and OB is median. So we can conclude that since OB is median, we can conclude that area of AOB is equal to the area of triangle BOC. Similarly, in triangle BCD, now we take the next triangle. In triangle BCD, OC is the median, so we can say that area of this triangle is equal to area of this triangle. So we can conclude that area of BOC is equal to area of COD. Similarly, we can prove that area of triangle AOD is equal to area of triangle COD, and in triangle ABD we can prove that area of triangle AOD is equal to area of triangle AOB. So from the equation 1, 2, 3 and 4 we can conclude that area of triangle BOC is equal to area of triangle COD is equal to area of triangle AOD is equal to area of triangle AOB. So the diagonals of a parallelogram, we can say that Diagrams of a parallelogram divides it into 4 triangles of equal area. Hence, we have proved. Let us discuss question number 4. In this question, we have ABC and ABD, two triangles on the same base EB on AB. Now it says, if line segment CD is bisected by AB at O, show that area of triangle ABC is equal to area of triangle ABD. We have to prove that area of this triangle is equal to the area of this another triangle. Now in triangle ABC, we can say that AO is median and CD is bisected by AB at O. So by this we can prove that area of AOC is equal to area of AOD. Now we can say that area of this triangle 1 is equal to area of this triangle 2. Similarly, we can prove that in triangle BCD, BO is median and CD is bisected by AB at O. So, area of BOC will be equal to area of triangle BOD. By adding 1 and 2, we can get ABC is equal to ABD, which should be our answer. Let us discuss question number 5. In this question, we are given that DEF are respectively the midpoints of sides BC, CE and AB of triangle ABC. Like this point, these 3 points are the midpoint of their respective lines. And in this question we have 3 subparts. In first part we have to prove that BDEF is a parallelogram. Like we have to prove that this is our parallelogram, the shaded region with the blue, and area of triangle DEF is equal to 1/4 of area of triangle ABC. So in the next part we have to prove that area of triangle DEF that I have shaded with the green is equal to the area of 1/4 of triangle ABC, which is our complete triangle. And in the third part we have to prove that area of parallelogram BDEF is equal to half of area ABC. Like now we have to prove that area of parallelogram BDEF is equal to half of area ABC. Now let us see how we will prove it. So for the first part, where we have to prove that BDEF is a parallelogram, we'll see in triangle ABC. Now see, in the triangle ABC, EF is parallel to BC. EF is parallel to BC, and if EF is equal to half of BC, EF is half of BC, we can conclude this by our midpoint theorem. And also BD is equal to half of BC, because D is the midpoint. BD is half of BC because D is the midpoint, so we can say that BD is equal to EF. So by this we can conclude that BE and DF will also be parallel and equal to each other. Thus the opposite pair of sides are equal in length and parallel to each other. We can prove that BDEF is a parallelogram. Let us proceed to the next part of our question. Now we have to prove that area of triangle DEF is equal to 1/4 of area of triangle ABC. So similarly since we have proved that BDEF is a parallelogram, similarly we can prove that DCEF and AFDE are parallelogram. So now we have three parallelograms in the figure. If you could notice, first parallelogram is AFDE, and the second parallelogram is BDFE, and the third parallelogram is FECD. And it is being divided by a diagonal EF, and BDFE is being divided by the diagonal FD, and DCEF is being divided by the diagonal ED. So we can conclude that we know that a diagonal divides the area of a parallelogram in two equal parts. So similarly, we can conclude that area of triangle BFD is equal to area of triangle DEF. And area of triangle AFE is equal to area of triangle DEF. So it says this area is equal to this area. And from 1, 2 and 3 we can conclude that area of all the triangles are equal. So by that we can conclude that area of triangle DEF is equal to 1/4 of area of triangle ABC. Now let us move to the last part. Now we have to prove that area of parallelogram BDEF is equal to half of area of triangle ABC. For this we can prove that area of parallelogram is equal to area of triangle DEF plus area of triangle BDE. Now area of parallelogram BDE is equal to 2 into area of triangle DEF. So similarly we can prove that area of parallelogram is equal to 2 into 1/4 of area of triangle ABC. Hence we have proved that area of parallelogram BDE is equal to 1/2 of the area of triangle ABC. Let us discuss question number 6. In this question we have a quadrilateral ABCD and diagonal AC and BD intersect each other at O, and it is given that OB is equal to OD. It is given that OB is equal to OD and AB is equal to CD, and we have to prove that area of triangle DOC is equal to area of triangle AOB. In the second part we have to prove that DCB area is equal to area of ACB, and in the third part we have to prove that DA is parallel to CB and ABCD is a parallelogram. To do this we have a hint from the textbook that from D and B we can draw a perpendicular to AC. So here we have drawn a perpendicular DE. Here we have draw a perpendicular DE on AC and FB on AC. Now let us try to solve this question. Now it is given to us that AB is equal to OD and AB is equal to CD, and after doing the construction we'll come up to our proof, and that is in triangle DOE and BOF. In triangle DOE, these two small triangles DOE, this small triangle, and BOE. First of all, we will consider these two triangles. Angle DEO is equal to angle DFO, and angle DOE is equal to angle BOF because it is vertically opposite angle. Angle OD is equal to OB, it is given to us. So we conclude that triangle DOE is congruent to BOF by angle side congruence condition. So by this we conclude that DE is equal to BF by CP/CT. It means by this we conclude that both the altitudes that we have drawn are equal. And by the same process, we can prove that triangle DOE is area of triangle DOE is equal to area of triangle BOF. So now in triangle DEC, the outer triangle, this triangle and this triangle which is AFB, angle DEC is equal to angle BFA, those are perpendicular, and CD is equal to AB, it is given to us. DE is equal to BF, we have concluded it from the first equation. So by RHS, these two triangles are congruent. So area of triangle DEC will be equal to area of triangle BFC. So by adding both these equations, equation number 2 and equation number 3, we get to know that area of triangle DOC is equal to area of triangle AOB. So coming to the next part, area of triangle DOC is equal to area of triangle AOB. We have just proved this in our first part, and what we'll do, we'll add area of triangle OCB in both these equations. So by that we can get area of triangle DCB is equal to area of triangle ACB. So going to the third part, we have to prove that DA is parallel to CB or ABCD is a parallelogram. So since in the last part we have proved that area of triangle DCB is equal to area of triangle ACB. Now if two triangles are having same base and equal area, it is quite sure that they will be between same parallel lines, which is DA and BC. And for the quadrilateral ABCD, one pair of opposite sides are equal and other sides or opposite sides are parallel, so we can say that ABCD is a parallelogram. Let us discuss question number 7. In this question, we are given that D and E are points on the sides AB and AC respectively, such that area of triangle DBC, the shaded with green, is equal to the area of triangle EBC, is equal to area of triangle EBC. This triangle is shaded with a glue. So we can prove it by that triangle DBC and EBC are on the same base, that is BC, and also having equal areas. Therefore they will lie between the same parallel lines. Thus DE is parallel to BC. Let us discuss question number 8. In this question, XY is a line parallel to side BC of triangle ABC. If BE is parallel to AC and CF and AB meet XY at XE and F respectively, we have to prove that area of triangle ABE is equal to area of triangle ACF. Now solving this question, first of all it is given that xy is parallel to BC. Look at the line xy, this is xy, is parallel to line BC, of course it is parallel, and B is parallel to AC, B is parallel to AC, second line, and CF is parallel to AB, and CF is parallel to AC. And we have to prove that area of triangle ABE, like area of this triangle, is equal to the area of ACF, sorry. So we have to prove that area of these two triangles is equal. So we'll start up with by proving xy is parallel to BC. Since EY is parallel to BC, we can conclude that both these lines are parallel. So by the same process, we can prove that BE is parallel to CY because BE is parallel to AC. So from 1 and 2, we can say that BEYC is a parallelogram because both the pairs of opposite sides are parallel. Similarly, we can prove that BXFC, this parallelogram, it is also a parallelogram because it is on the same base and between the same parallel lines. Accordingly, area of BEYC and BXFC is equal. Why? Because parallelograms on the same base and between the same parallel lines are always equal in area. So we can give it a equation number 3. And now moving further, triangle AEB and parallelogram BEYC lies on the same base. Triangle AEB, this triangle, and parallelogram BEYC and this parallelogram, which I covered with green, are on the same base and between the same parallel lines. Here the base is BE and the parallel lines are BE and AC. So we can say that area of triangle AEB is equal to half of area of BEYC. So similarly, we can prove it with the triangle ACF and the parallelogram BXFC. This is the other parallelogram BXFC, and this is the other triangle. So from the equation number 3, 4 and 5, we conclude that area of triangle AEB is equal to area of triangle ACF. Let us discuss question number 9. In this question, we are given that side AB of a parallelogram ABCD is produced to point P. That side AB of a parallelogram is produced to side P. A line through A and parallel to CP meets CB produced at Q. That this line meets here, and then parallelogram PBQR is completed. Then PBQR, this parallelogram that I have shaded with the color green, is produced. Now we have to prove that area of ABCD is equal to area of parallelogram PBQR. We have to prove that the area of this parallelogram is equal to the area of this parallelogram. So to do this question, we first of all have to join AC and PQ. So we have joined AC and PQ, And then we will compare the area of ACQ triangle ACQ and this triangle, and the another triangle is APQ, this triangle. These two triangles we will compare. So let us try to prove this question. We know that AC is and PQ are joined, so area of triangle ACQ will be equal to area of triangle APQ. Area of this triangle will be equal to the area of APQ. Why? Because these are on the same base and on the between the same parallel line, which are AQ and CP. And now we will subtract the area of ABQ from the both sides, from both these triangles, and we get area of triangle ABC equal to area of triangle QBP. We give it equation number 1. And now AC and QP are diagonals. Now AC and QP are diagonals of ABCD and PBQR. So area of ABC will be half of area of ABCD. Like this is a triangle. So area of this triangle will be equal to half of its parallelogram, and again area of this triangle will be equal to half of its parallelogram. So from equation 2 and 3 we can prove that area of triangle ABCD is equal to half of area of triangle PBQR. Since so we can prove that, hence we can prove that area of triangle parallelogram ABCD is equal to area of parallelogram PBQR. Let us discuss question number 10. In this question we have a trapezium ABCD and its diagonals are AC and BD, with AB is parallel to DC. We have to prove that area of triangle AOD, area of this triangle, is equal to the area of triangle BOC. So to prove this question, first of all we will prove that area of triangle DAC is equal to area of triangle DBC. Like area of these two triangles, area of this triangle is equal to the area of other triangle. We can prove that the area of these two triangles is equal because they lie on the same base and between the same parallel lines, which are AB and CD. So by subtracting area of triangle DOC from both these triangles, we can prove that area of triangle AOD is equal to area of triangle BOC. Let us discuss question number 11. In this question we are given that a pentagon ABCDE a line through B which is parallel to AC is produced to the point F, and we have to prove that area of triangle ACB is equal to area of triangle ACF. We have to prove that area of this triangle is equal to area of this triangle ACB. In the second part we have to prove that area of AEDF is equal to area of ABCDE. So first part is we have to prove that area of this triangle is equal to this triangle, and in the second part we have to prove that area of AEDF, area of this quadrilateral is equal to area of pentagon ABCDE. So let us try to solve this question. So for the first question, since A in triangle ACB and ACF, both these lies on the same base which is AC and between the same parallel lines which are AC and BF. So we can say that area of triangle ACB is equal to area of triangle ACF. And for the second part, since our triangle ACB is equal to area of triangle ACF, if we add our quadrilateral ACDE, if we add our quadrilateral which is ACDE, if we add this quadrilateral to both these triangles, we can prove that area of triangle, area of pentagon ABCDE is equal to area of parallelogram AEDF. Let us discuss question number 12. In this question, a farmer has a plot of land in shape of a quadrilateral. He has a plot in shape of this quadrilateral, and the Gram Panchayat of a village is decided to take over some portion of this plot from one corner of the plot to construct a health center. जो पंचायत है वो वहाँ पे एक हेल्थ सेंटर बनाना चाहती है. So they asked the farmer to give his plot. The farmer got agrees to above proposal, लेकिन उसकी कंडीशन है कि जितना भी वो लैंड का पार्ट लेंगे उतना ही उनको उसके प्लॉट के साथ उनको देना पड़ेगा ग्राम पंचायत को. So we have to explain that how this proposal will work. So for this proposal, to explain this proposal, we will do some construction. सबसे पहले हम क्या करेंगे, जो डायगोनल BD है we will join both these two. B को D के साथ ज्वाइन कर दिया, एंड आफ्टर दैट B और D के जो पैरेलल एक लाइन बनाई एंड वी गेव इट नेम एज E, और उसके बाद हमने E और B दोनों को ज्वाइन कर दिया, और जो इंटरसेक्शन D के साथ हो रही है वी गेव इट द पॉइंट नेम एज O. It can be easily seen in this in the figure below. So now what we'll do, we will construct the healthcare center in triangle AOB and give the land to the farmer EOD. So ultimately our question becomes, we have to prove that area of triangle AOB is equal to area of triangle EOD. So to prove this, first of all we have to look at this parallelogram. Since AE is parallel to BD, we have to concentrate on this parallelogram only. In this parallelogram, area of triangle DEB will be equal to DAB because they lie on the same base which is BD and between the same parallel lines BD and AE. So our area of triangle DEB is equal to DAB. So by looking at these two triangles, we can observe that triangle DOB is common between triangle DEB and DAB. So if we subtract triangle DOB from both these triangles, we can prove that triangle DOE, triangle DEO is equal to area of triangle AOB. Let us discuss question number 13. In this question, we are given that ABCD is a trapezium with AB parallel to DC. A line parallel to AC intersects AB at X. Now it says we have a trapezium ABCD and a line which is parallel to AC intersect AB at X and BC at Y. Now we have to prove that area of triangle ADX is equal to area of triangle ACY. So ultimately we have to prove that area of this triangle is equal to the area of this triangle. So let us try to solve this question. Now we are given that ABCD is a trapezium with AB parallel to DC, and XY we construct and CX is joined. Now going to the proof, we know that triangles on the same base and between the same parallel lines are equal. So area of ADX will be equal to area of AXC. So the area of ADX, this triangle, will be equal to the area of AXC, this triangle, because both of them are on the base AX and between the same parallel line AB and DC. Similarly, we can prove that area of triangle AXC is equal to area of triangle ACY. See this area AXC is equal to ACY, this triangle this triangle, because their base is YC and AC, and they are between the same parallel lines XY and AC. So from 1 and 2 we can conclude that ADX is equal to ACY. Thank you. Let us discuss question number 14 now. In this question we are given that AP is parallel to BQ and BQ is parallel to CR. Both these three lines are parallel to each other. We have to prove that area of AQC is equal to area of PBR. So ultimately we have to prove that area of this triangle equals to area of this triangle. So we can prove that area of AQB is equal to area of PBQ. Because they are on the same base, which is BQ, and between the same parallel lines AP and BQ. Also area of triangle BQC area of triangle BQC is equal to area of triangle BQR, because again they are on the same base and between the same parallel lines. So adding 1 and 2, adding both these equations, we can prove that area of triangle AQC is equal to area of triangle PBR. Let us discuss question number 15. In this question, diagonals AC and BD of a quadrilateral ABCD intersect at O in such a way that area of triangle AOD, area of this triangle, is equal to area of BOC. Now we have to prove that ABCD is a trapezium. So ultimately we have to prove that AB is parallel to CD. We have to prove this. We know that area of triangle AOD is equal to area of triangle BOC. It is actually given. So by adding up AOB, adding up area of triangle AOB on the both sides, we can prove that area of triangle ADB is equal to area of triangle ACB, like area of this triangle ADB, area of triangle ADB is equal to the area of triangle ABC. So which is only possible when they are lying between the same parallel lines. So we can prove that AB is parallel to CD and therefore ABCD is a trapezium.